Ever noticed how online stores recommend exactly what you need? That's what we're talking about in this video, because data is the new gold. Today, we're breaking down data science versus big data with real-world applications in retail, finance, and healthcare, backed by Jelvix expertise. So let's get started. First things first, let's clear up the confusion through the perspective of our teams. We know that data science and big data go hand in hand, but each serves a different purpose. Our data science team focuses on extracting actionable insights using analytics, machine learning, and statistics, helping businesses make informed decisions, predict trends, and automate processes. Powered by technologies like AI, predictive modeling, and automation, data science is utilized by business analysts, data scientists, and AI engineers in data-driven projects. Meanwhile, our big data engineers manage the storage, processing, and organization of massive structured and unstructured datasets. They ensure data is accessible and ready for real-world applications. Tools like Hadoop, Spark, cloud storage, and NoSQL support Jelvix experts handling big data projects, including big data engineers, IT teams, and cloud architects. So, data science is about turning data into insights, while big data is focused on managing and processing vast datasets. Now, let's see how these technologies are applied in key industries. We're Jelvix, your software development partner. Are you subscribed on our channel? We post weekly videos on tech in 5 minutes, so stay with us. First, let's explore the power of data science and big data in retail. So, how do online stores know that you need a shower head, a tarantula model, and a vacation in Italy? That's data science using AI-powered recommendation engines, like the personalized shopping assistant Jelvix built for an e-commerce giant. But here's the issue. Such recommendation systems require constant data updates. If not updated in real time, they can fail to adapt to shifting consumer behaviors. But there's a way to resolve this. For example, by integrating real-time insights from browsing behavior, purchase history, and feedback, and regularly updating algorithms to reflect changing preferences and trends. Meanwhile, big data allows retailers to analyze billions of transactions to uncover market trends. For example, Jelvix optimized inventory management for a major retailer by leveraging data from point-to-sale systems, supply chains, and customer reviews, ensuring the right products were stocked at the right time. However, consider that working with such massive datasets requires high processing power and storage, which can be costly. Without the right infrastructure, businesses may struggle to extract meaningful insights. Another area where big data and big science make a big impact is finance, which runs on data science algorithms that detect fraud in real time. In doing so, AI models analyze transaction patterns and flag suspicious activities right before fraud occurs. Meanwhile, big data powers high-frequency trading, where financial firms analyze petabytes of stock market data in milliseconds. It enables them to scale their trading algorithms efficiently. However, both data science and big data in finance pose their challenges. For example, AI-driven fraud detection can lead to false positives, frustrating customers and causing disruptions. Meanwhile, big data in finance requires costly computing resources and real-time processing, and poorly managed trading algorithms may contribute to market volatility. To mitigate these risks for AI-driven fraud detection, Jelvix suggests implementing more sophisticated algorithms to reduce false positives, such as machine learning models that adapt to evolving fraud patterns. Plus, incorporating customer feedback loops can help fine-tune the detection system. For big data, optimizing data processing workflows can minimize latency, and continuous monitoring of trading algorithms ensures proper risk management. Moving on to healthcare. In this domain, data science powers predictive analytics, AI models that analyze patient data to predict diseases before symptoms appear. For example, a health analytics platform that detects early signs of diabetes and cardiovascular diseases. By processing a combination of historical patient data, lifestyle factors, genetic information, and real-time health metrics, these AI-driven models not only improve early diagnosis, but also enable personalized care plans and reduce healthcare costs. However, the accuracy of data science in healthcare depends on data quality. If AI models train on biased or incomplete datasets, predictions can be inaccurate, leading to misdiagnoses. So to tackle this, Jelvix experts recommend ensuring data diversity, validating and cleaning datasets, and continuously updating AI models with new patient data. While big data improves efficiency and access to medical data, it also introduces challenges related to security and privacy. Managing such vast amounts of sensitive health information requires compliance with regulations like HIPAA and GDPR. Meanwhile, big data enables secure storage and processing of medical records, IoT sensor data, and clinical trials. Jelvix experts have helped hospitals integrate electronic health records with digital health solutions like heart rate monitors, glucose sensors, and telemedicine apps, ensuring real-time access to critical patient data. Summing up, data science focuses on extracting actionable insights through analytics and machine learning, while big data handles the storage, processing, and management of large data sets. Don't miss checking out our dedicated video to learn how to generate insights from data in no time. And of course, support us by liking this video and leaving a comment. Don't forget to subscribe and hit the bell button. Bye for now.